basically, hi, my name's Jiarui, and I created Dynamic Fit, which is an App Store application that aims to solve the problem as shown here, right? Like, so obesity is kind of like a lack of healthy habits is a severe problem that like a majority of population in the world, like a lot of people struggle with. So like from and according to data, like starting from 2015 to 2016, 47% of all American adults were considered obese. Obesity can lead to major health problems such as high blood pressure, coronary heart disease, strokes. For those who are trying to improve and are just starting their fitness journey, it will be difficult to know where to begin. Uncertainty in fitness goals can potentially lead to injury. So basically, you need to like have a correct move. So this app serves to like promoting fitness lifestyles and encouraging participation by exercising, right? So using our application, the user will find it convenient to select the exercises in the areas they want to focus on. For example, like if they could do like push-ups and things like that, right? So, and also like my, so basically like also like beginners will be injured from like improper movements, which can be prevented using demonstration videos for correct movements and exercise descriptions from the application, right? So the application is my application is able to make recordings of the count of the number of repetitions per set for every exercise. So this significantly contributes to like promoting healthy habits because they won't be injured and like they won't like they have healthy exercising habits, right? Um, so this app solve the problem of like having to find a personal trainer, right? So like personal trainers are expensive and they require like a lot of commitment. And so like it provides a cheap substitute for a personal trainer in this case by being able to use artificial intelligence to correct the incorrect movements of the user, right? So yeah, so let's start exploring the components, right? So here's first demonstration video. So do I just play the video? Hello, my name is Jiarui, and I'll be presenting Dynamic Fit. It is an iOS App Store application that uses AI to analyze exercise moves for the user, and it solves the problem of obesity and unhealthy fitness habits. Taking a look at the project code. Here we have the pose detector file, which contains detector class. The detector class is used to handle media pipe, which is an AI model used to analyze human body parts. And it contains important methods to track information about the body, such as here we have angle of joints. The get angle method requires three body parts, such as shoulder, elbow, and wrist, to calculate the angle of the elbow. This is one of the many exercise analyzers that uses pose detector to track the user's movements during the specific exercise. This example uses the push-up exercise. These are the variables used to track the progress of push-ups, such as half completed and is down. The process method is the main method used to analyze each frame of video to track the progress of the exercise. And these error programs check for the potential errors made by the user. The fitness analyzer combines all the analyzers from different exercises into one method that could be easily used to read any exercise, as you can see here. This part manages the video and makes sure that each frame is given to the correct analyzer. And lastly, after the entire video has been analyzed, the fitness analyzer will store the result into a Firebase database. This is a server file. In order to connect to the fitness analyzer with the mobile app, I am hosting a Flask server that can communicate information and data between the two programs. And here, using the route/exercise video, the mobile app is able to submit a video of an exercise to the fitness analyzer. And then the results are posted to a Firebase storage and is returned to mobile app to allow the users to view the results of their exercise. So next, we will move on to showing our applications. Starting from the home page, you enter the application, and here you see a splash screen, and here there is a carousel of like different exercises you could select. And here we will select the exercise, jumping jacks, yeah. And here's a brief description of the exercise, and down there is demonstration video. As you can see here, it's showing how to do the exercise, and you click start exercise anytime, and you can import media or record a video, and then you click into and you select it. For example, in this case, I select a video, and then it's loading, and that's finally done. And you can see the analyzed video here. It's loading, and it works. And you can see it shows the angles of critical body parts and counts the amount of reps you did and shows possible errors. Hello, my name is Jiarui, and
Sorry, yeah. So here's a summary of the components, as I said, it just more detailed, right? So exercises, fitness analyzer, AWS server, Firebase storage, and Flutter. So these are the components I use. So first is the exercises. So here's a list of exercises. So jumping jacks, things such as jacks, push-ups, or pull-ups, right? Right, like in the files, I included program for like counting how much reps are done and like the conditions for like the possible errors that the user is making, right? Like, so for example, the arm angle must be greater than 50 degrees or something, right? So here's a fitness analyzer. It's just for conveniency, right? Because it combines all of the exercise analyzer into one single analyzer, which exercises can easily like extracted from. Because if you have single, like exercise files, it wouldn't be as convenient because like you would need to manage each of the files corresponding to the condition that like the exercise I want to do, right? So just combining it into one and then calling it using the server will make it a lot easier. And here is a brief analysis on AWS server, right? So it allows for communication between two different programming languages. It also like allows me to host it online so that when I close my window, the program's continuing to run. So lastly, it serves the purpose of extracting media from Firebase depending on exercise that user selects. So basically, they select an exercise, and depending on what they select, I need it to like automatically communicate with the Python programs to like fitness analyzer to select the exercise I actually want, right? So right, and in this case, right, like I'm converting .py files to .dart files, which is like Flutter, right? And Firebase storage. So it's used to store videos and images online so that the server can extract it easily, like anytime based on what that exercise the user selects. So basically, it provides an online database for me to put the pictures so that like, for example, if they click on pull up, I would need the program to show the user the demonstration video for pull up and the like the picture of a pull up, right? So you can see, so it's a Firebase sending the image and video to Flutter, which brings us to the next topic, right? So Flutter is managing like the display. For example, this window, right? Here, each of the components, such as like this image and this text box, right? Like image and this is carousel, right? Carousel of images, right? So, like it's Flutter manages the storage of these components on the screen. So it's like I just do things such as like um to make a frame like so that I could put my images in, right? So and it's managing the you could say the page swapping function also. So yeah. So in this application, I use artificial intelligence and machine learning. So the main thing is media pipe. So it's like it detects joints in the human body for future use and calculations such as calculating the angles of joints to detect the completion of a repetition in the exercise. Because like when I thought of the thing at first, I thought about like using the length of a body part, but like I feel like it wouldn't work. I would need something that will be constant the no matter like the if it's high pixel or low pixel, right? So this works, right? So because the angle of it, I could calculate like for example 50 degrees of an arm, like greater than 50 degrees, that means like one rep is completed. So that's a good indicator. And second, it's use of augmented reality. So it's like basically, for example, here, putting the things on top of a screen, like on top of a video, right? Like right here, right? So for this, I use CV2. So it's used along with MediaPipe to complete the process of analyzing video, then annotating it. Like it labels on the source of media or like import videos or recorded video, right? By writing out on the potential errors that the user is making in text boxes. So things such as like amount of reps and angles of crucial body parts, as you can see here, and the 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 error they made, right? So it's not shown in this case, but it will be shown if the move is incorrect. So as you can see here, like the original imported media is just this person doing the pull-up video thing, right? And after CV2, they added on the points for crucial body part. That's why I say like it's connected to media pipe and also here, right? In future development, I'm planning to create a login page so that people can track their fitness progress and goals. And also create a nutrition page as a new function for like, like more things that this app encompasses, right? So this and then so I'll try to make the more detect errors more accurately and we're providing more conditions, right? So here's a table of data. As you can see, the error is like pretty low, but like there's still some error. So I'm trying to minimize it. And you can see the graph here. In this case, as you get closer to the line y equals x, the closer it is, the less error because it's expected results versus observed results. So it's like the slope should be one if it's perfect, right? And yeah, here's this like chart, like the higher the exercise. So as you can see here, the squat has the most, like the highest error, and the pull-up has the most frequent error. So here is the modeling, right? So what we hope for is no error, right? So it's like this, right? So the rate of error is zero. So yeah. And in this case, the area under the curve for functions represents the total amount of count errors for repetitions because it's the rate, right? So the hypothetical that what we guessed was like so basically the integral equals base times height, right? So it's a rectangle, right? So we want to make sure it's a systematic error instead of a random error, which in this case is a reality, right? So we don't know the error is. Sometimes we get less exercises and sometimes we get more exercises, like more reps and less reps, right? So so for the negative part, since negative, so like if you do one less exercise versus one more exercise,